All right, so let's set up a repository for us to practice these merging workflows. If you'll go ahead and clone the repository shown on the screen, this is a public GitHub repository that I set up in order to facilitate today's lesson. It is a repository that has a few commits in it already, a couple of branches, and the gist of what we're working on today is a number guessing game. That's like a binary search, right? So the computer is going to ask, I'm thinking of a number between 0 and 255. What is it? And it will tell you higher or lower as you guess. It's a C-based project, as we'll learn in a minute. Once you've cloned this project at that URL, remember a clone sets up a subdirectory in your current working directory. So we need to navigate into that directory. There will be some files in it, as well as the .git directory, which is the hidden directory with all of the data that Git needs in order for it to serve as a source code control repository. We're then going to list the branches, and this -- all flag is saying not only list the local branches that I've been working with locally on my computer, but also list the branches that have been pushed to the remote repository that has been set up. So you'll see a common word, origin, and origin is just a name of the default repository that is remote that you cloned from, right? So when we clone, we made a copy of this repository locally on our machine at that point in time, and it's set up, that remote repository is set up under a name called origin. And that's just a convention used in Git. You can have multiple remote repositories, but that's the subject of another lesson. Lastly, what we're doing is we're asking Git to present a log of the commits that it knows about, and we're setting some flags that will cause its output to be in a certain format. So we want the graph format, so this will connect nodes to one another and show us a textual but also visual history of our Git repository. We want each commit to take up only one line, meaning show me only the message of that commit, and list all commits similarly, not only from the branch that we're currently working on, but all of the ones that we know about. Okay, and so this is a simple repository. This is going to output something pretty reasonable. So let's take a look at what happens when we do this. All right, so here I did the clone that you all did, and I navigated into the workflow directory, Git workflow. Notice that that's the same as the name of the repository on GitHub. And when I listed my branches, not only did we see master, which is the default name of the branch that we cloned, but we also see some information about some of the branches that exist on the remote repository, right, named origin. And the two branches that we'll interact with later on in today's lesson are count. We're going to count the number of turns that it takes someone to complete a game. That's a new feature that's being worked on in that branch. And then in this branch, we're improving the welcome message, right? So we'll come back to those. And then in this last command, git log, we're presenting a history of and trying to display the output of the history of commits in our repository. And I want to start from the beginning. So our initial commit was this one. And so each of these asterisks that you see is an indicator that this was a commit, right? And so this is a commit, and it was followed by a commit that is add hello world to our repository. So this is me just getting this project set up and then adding a little bit more functionality. And so notice these are commits that are happening in order. And then lastly, this is the commit where I actually made progress and set up a number guessing game in C. From that, and notice some extra annotations for this particular commit, right? So the commit message here was make a simple number guessing game. This is telling us that we are currently the head of our repository, meaning the branch that we are currently working on is the master branch. And there are some remote branches associated with this. So not only is origin master on this exact same commit, but so is the head of the remote named origin. And we'll talk about tagging at some other point, but we're saying this is the 1.0 of our project, and this commit was tagged. On the remote repository, so notice there are the two branches I mentioned here, there are two other commits that are in those branches. And so notice that on the remote repository, the history is branched off in two directions. And so this is what these dashes are trying to indicate in a textual form to give us a little bit of a visual sense of the history here. And we'll come back to this as well. All right, so if we run that same command again, but we don't include the -- all. In fact, I'm going to clear my screen first and then run that command so that so you have a clean output. Notice that when we don't include that all flag, what we're saying is give me the log of commits from where my head currently is. And so head is at master, and then these are the history of the commits to come before it. Right? And so this is the same representation that I'm trying to present in the slides, right? So here we've got 2 commits and there's one that came before it. The master branch is what's in this purple box, and head is on master. So if you list the contents of the repository, you'll see there's a main.c file. This has the source code for the game itself. We've got a make file. This is our configuration file for how the project gets built. We've got a readme file and a .getignore file. As a reminder, the .getignore file will specify what built objects in this project or what configuration objects files in this project aren't going to be included in the repository in the future. As we've seen with make, this project's make file is pretty simple. There's a make rule. The default rule will build the project and it will result in an executable program named app. And then there's a clean rule for us to easily delete that file and anything else that might have been built. So we can try running the program by building it with make and then running it with /app. So let's try that. So this is me doing that earlier, and you can see that I built with make, and then when I ran /app, I started playing the game. I used the Control-C key combination to quit the application before completing the game, but you're welcome to complete the game if you'd like. Okay. Now let's try adding a new feature. We want to make the game more challenging. So what we're going to do is set up a feature branch, right? And this slide represents, the diagram on the right represents what is our end goal for these next set of steps. We want to establish a new branch named feature challenge, and we're going to use the feature dash prefix as a convention for a feature branch. And we want to check that branch out such that the branch that we're actually going to be doing making new commits to is the feature challenge branch, right? So we can do this in 2 steps with get branch feature challenge. That is what would establish the new branch, and then get checkout feature challenge is what would cause head to move from master to feature challenge. But as we've seen, we can also do this in a single step with get checkout -b and then the name of the new branch that we're checking out. So this does both of those steps above in one go. And this is typically the way people will set up a new branch because it's so much quicker and easier. Once we do this, we can confirm that we have actually made a new branch and checked it out with the get branch command, right? So let's try doing this. Let's try taking a look at this. So get checkout -b feature challenge. And now if I do the if I give the get branch command, we can see that the checked out branch is feature challenge. I'm not on master anymore. If I go back up in my history and look at my log, and notice again, I'm only going to log from where my head currently is. I just want to point out that currently our head is on feature challenge as we're seeing in that diagram, but we're also on, like this commit is also the commit that master refers to, right? So both feature challenge and master are branches that are currently both referring to the exact same commit in our repository. We haven't made any new commits yet. We've only set up this feature branch and made sure that we're working on it with our head referring to it. So now we're ready to begin playing around with a new feature. Okay, so what I'd like you to try next is a hands-on. I'd like you to try opening main.c, making it such that the user is guessing between 0 and 511. You'll want to make sure that the message is changed, indicating that's what the user is guessing from, but also the implementation of the logic or the bounds of the game as well. Once you have done this, try running it with make, playing it, and convincing yourself that your changes are successful. Once you've done so, go ahead and add main.c to the Git repository's staging area. You can check that with git status, and then make a commit. And the commit message will be increase the range from 0 to 511 or something along those lines. Once you've done these things, you can again try the git log command to convince yourself that what you've done is you've made a new commit on the feature challenge branch, as you're seeing on the right-hand side, and head is still on the feature challenge branch. So master still refers to the commit that came before it, but feature challenge has moved forward and now has this new commit in it. Once you've done that, you can resume the video and we'll keep moving from there. Okay, so I've gone ahead and made those changes to my game. I've tried compiling it with make. I tried running the application. I can see that my message has been updated, and I had to run this a few times, but eventually after I guessed 255, it told me that the guess was higher, and this allowed me to convince myself that sure enough, the bounds of my game were improved as well. Right, so I haven't yet made my commit, so I'll do that next. So currently, if I were to check git status, we see that main.c has been modified, but is not in staging. So if I add main.c to my staging area and check my status again, we see that sure enough, this is ready to be added to a new commit. This is a change ready to be committed. So if I make a commit, git commit with my message m, and let me just confirm that I'm using the same message I said here, increase range from 0 to 511. Increase range from 0 to 511, and I've made that commit. All right, so I'm going to clear my screen and once again look at this history. It's way up here. I should have just typed this out, but there it is. Okay, and so let's take a look. And what we're seeing here is the head of our repository is still on feature challenge. This was the commit that we just made, and notice that the commit that came before it is the branch that is the commit that the master branch still refers to, right? So master stayed in place, and because our head was on feature challenge when we made that commit, we're saying extend the feature challenge branch or make a new commit and move the feature challenge branch forward with that commit and keep head on it because that's the branch we're currently working on, right? And so notice that this is a linear history, right? This is one after the other after the other. And so in the slide deck, the distinction that I'm making here that we actually went off in some separate direction is kind of arbitrary and not necessarily true. Like we could have imagined this linearly, such that there's no actual spatial relationship between these things. The only relationship is that this commit that we just made on the feature challenge branch comes after or was preceded by its parent is the commit that was on the master branch. Okay. So next, I want to make another simple little change to our project. I want you to try following along with this. In main.c, we're going to print a new message that's something like welcome to my awesome game before the line of I'm thinking of a number. And we're going to add those changes and make another commit with another message. And that will cause a second commit to be on this feature branch. Okay, so I'm going to quickly open main.c and use another printf here. Printf, welcome to my awesome game. All right, and so I'm going to save that with a :w to write my contents out, or I could have done ZZ. I'm done with that. And let's make our project and test it out real quick. Oh, I forgot to add a new line character, so I'm going to go in and, oops, I'm still in my game, so I'm going to have to Control-C to quit my game, and then vim main.c. I want to jump to the word game, so I'm going to do the /, which is, remember, a regular expression search game. That will jump me there, and then E and the arrows will get me over to be able to insert \n. All right, so I saved that, try it again, /app. There we go. We've got a line of text, welcome to my awesome game, and then the prompt. So it looks like we're good to go. All right. So what I'm going to do is I'm going to add that main.c file back to my project, or back to the staging area. And I'm going to check the status of my commit. This is always a good habit to be in. Just be sure that when you make a commit, it only has the changes you want. Here we know that that's the case. So I'm going to make a commit, which is add a better welcome message. Right? This game is getting pretty good. So we've made that commit. And if we wanted to once again visualize this history, notice that head is on feature challenge. There was the previous commit that we made on this branch, but master is still a couple of commits back in the history. Right? And so now our history looks much like we're seeing on this slide. And we're ready to think about, well, how do we actually merge these two branches back together? All right. before we think about merging, we have to remind ourselves, how do we change branches? How do we get back to some previous or some alternate branch in our project? So when you check out a branch, right, the act of checking out, what this checkout action is doing is it's saying, hey, move my head so that I'm not working on feature challenge anymore, but I'm actually working on master. So when we check out master, head will move to master, and that relationship will be established that head knows it's working on master. But additionally, the files that are in our current working directory are going to be substituted with the point with all of the files as their contents existed at this point in our project when this commit was made. Okay, so the commits that we had seen, the changes we had made to improve the difficulty of our game, those are going to go away when we check out master, because we're going back in time to the commit that we were working on previously. All right, let's try that out. I'm going to clear my screen, git checkout master. And if we run the git branch command, we can convince ourselves that, yep, sure enough, we're now checked out. We're on the master branch. And if I were to make my project one more time and run it here, /app, notice we're back in the state of our project where we're thinking of a number between 0 and 255, right? We've reverted back to where our master branch was. So I'm going to, once again, use Control-C to end my program. And that's all it takes to jump back and forth, right? You don't need to do this next step, but if I were to once again check out feature challenge and rebuild my project and run app again, notice that we're back where we were when we were working on the challenging feature, right? And so this is the superpower of Git, the ability to very quickly jump between branches and work with this branching model in mind is one of the big reasons people fell in love with Git as a repository, as a source code repository system. So git checkout master, make one more time, right? And so we can easily jump back and forth between branches just like that, right? So now the question is, how do we bring these branches back together, right? How do we actually incorporate this feature that we want to have in our mainline, right? So master is our mainline branch. We want to incorporate this feature back into it. And this is where we have two options, right? So one option is we can do a fast forward merge. We actually looked at this earlier on when we first looked at merging in Git. The idea of a fast forward merge is that, hey, it looks like there's actually a single linear sequence of commits here, right? And so previously, the master branch, the master branch was on this commit. And it looks like if we just changed that master to no longer refer to that commit, but just refer to this one, in essence, we fast forward it, right? We move it along this history of commits until it reaches the same it refers to the same commit as the feature challenge, the branch that we're merging with. Then that's what a fast forward merge is. This is possible when you have a linear history of commits that work like this. Okay, and so since we previously looked at this, we're not going to try a fast forwarding merge here. But the idea is we're effectively just saying, hey, because feature challenge was a linear history from where master was, we can just fast forward master to point to the same thing that feature challenge did, and that's how we would fast forward merge. The downside to this is you kind of lose the history that this was a separate branch, right? That this was actually its own separate history, right? Once we do this and say that master and feature challenge are both the same commit here that was in the previous feature challenge, this is a linear history. We have no sense that this was a separate branch once we get rid of the branch named feature challenge, right? So what we're going to actually spend most of our time focused on today is a different kind of branch called a merge commit. And I want to give you the visualization of this before we jump into the mechanics of it. So a merge commit, notice, is going to be a little bit different. This is going to be a merge commit. And what is a merge commit and what makes it interesting? Well, notice that it has two parents, right? So its parent is the previous commit in master and the previous commit in feature challenge. And so we can force Git to create a merge commit even when it could otherwise fast forward if we want to. And the reason that many people do choose to do this is because it keeps this history of having worked on this feature challenge off in its own branch. So that at some point later, if you needed to revert some parts of this branch, you would know the ones that were specific to actually implementing it and were separate from any other types of features you are working on separate from it. Right? And we'll see this again in the future as well. But the big idea of a merge commit is that it's a commit with two parents. Previously, we've seen commits could only have one parent. Right? So let's try actually making a merge commit. And what we're going to do is, in order to merge one branch into another, we currently have this particular commit checked out as master. And when you merge, you're saying, hey, I want to take my current branch and incorporate some other branch into it. So we're going to merge feature challenge into master, right? So in order to do that, we're going to have master checked out, which we already do. And we're going to run this git merge command right here, right? So let's give this a shot. Let's try merging, and notice this -- no ff is short for no fast forward. Okay, so I say git merge no ff, and then feature challenge is the branch that we're trying to merge in. Okay, so this takes me to a Vim editor that allows me to modify the commit message, right? So we are creating a new commit. This is us creating the merge commit. And maybe what I'll do is I'll press DD to delete that whole line, and then insert, say, a message of merge commit bringing in feature challenge. Okay. So once I save this and write it out, capital ZZ, notice that it says the merge was made by a recursive strategy. The files that changed in this process were main.c. Those were the changes we made. And so now, if we look at our history one more time, and once again, I probably should have just written this out, but now we can actually see that merge commit in the history of our repository. All right, so head, where we currently are, is on master. Notice this was the commit that we just made. We're merging feature challenge into the master branch, right? And so this was the last commit on master before. This was where we were before. And the commit that we just made was this merge commit that merged master with feature challenge, right? And moved master forward, because that was the branch we were merging into, to be the one that has that merge commit as a part of it. Notice that this feature challenge branch is still separate from master, and on its own, the history of it is retained in our repository. All right, great work. So you've made your first merge commit in Git if you haven't done this before. Okay, so what's special about this? Well, again, notice that there are two parents here. So even though we often think about repositories as linear or trees, in reality, as we mentioned before, they're directed acyclic graphs. So each commit has parents, and each commit can have potentially more than one parent, but you can't have any that are self-referencing, and you can't have any cycles in this graph of commits as well. There's always a path back from the current commit back to the very first commit in a repository.